Hello everyone, it's September 18th again. Alright, let's see. The question is called find duplicate file in system. Oh yeah, I've done this before. I thought it was a new problem. Alright, let's see. Given a list of paths, include the directory path and all the files with contents in this directory. Return all the duplicate files in the file system in terms of their path. You may return the answer in the order. A group of duplicate files consists of at least two files that have the same content. A single directory info string, the input has the following format. We have a root, blah, 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 up into... Oh, we also have content. Oh, okay. It means there are n files inside this directory with content, respectively in the directory this. Note that n is larger equal to 1. Where is n? So f1, f2, all the way to fn. And n is larger equal to 0, so we have... Oh, then we don't have d. So root is basically d0. The output is a list of groups of duplicate file paths. For each group, it contains all the file paths of the file that have the same content. A file path is a string that has the following format: directory path and a file name. Okay, so let's see. Paths, we have root to A, we got two files. Root and then C. Okay, these two are the same. And root cd4. This is also the same. So when we return, what do we return? We return root a2.txt, root cd4.txt, and then root 4.txt, and root a1.txt, and then root c3.txt. I see. So we just need to parse this. This is actually something that you will probably use in your work or in real life when you have to, like the first, if you do data analysis and this is the first thing you got is just a bunch of files, right? A bunch of files, and you have to categorize them, put them into their own folders, dereplicate. Deduplicate is a big thing. It's a big thing. So this is basically deduplicate while you know exactly what the contents are for each of them. In reality, it's possible. If you want, you can hash a whole file, right? You can use UUID hash. Then you can attach like the hash string, and then you compare the hash string for that. That's something you can do. All right, let's see. Contains this blah blah. You may assume no file directory share the same name in the same directory. Okay, each given directory info represents a unique directory. A single blank space separates the directory path and file info. Okay, so this just kind of makes things easier. So what's the follow-up? Imagine you're given a real file system. How will you search files? DFS for sure. How can you do BFS? You can run out of... Oh, hold on. I need to DFS. You might run out of stack space as well. But in a real file system, I would say the depth is definitely a tree, very fat, very wide tree. You can have tons and tons of folders on the same level, but I don't see you have... Basically, you just decide, is it more depth or more width? I'm of the opinion that it will be more width than depth. That's my opinion. If the file content is very large, like I said, you have to hash it. If you can only read the file by 1 KB each time, 1 KB each time, that's a good thing. I mean, we can do just 1 KB each time, I guess. I read 1 KB and then There gotta be a way to hash a file, a large file, that by reading only 1 KB each time. The time compressed if you modify solution. It means reading the file. Reading the file is always the most time-consuming part. Are not false positives. I mean, if we hash, I mean, if we can only read 1 KB at a time, we can read a couple KB, right, from the front, and then I mean, we can run just a couple KB from the front, and we hash based on that. That might work. If you want to read the whole file, that's going to be hard. But anyway, let's solve this one first. So what do you think? Well, we have the path, so each one we can get the content. What's the length of the content? $3,000, at most $3,000, all right? That's fine. So we get a content, put in a dictionary, make this into a path. So this will be root a/1.txt. And then voila, we're done. Yeah, the problem itself is not that hard, but the follow-up does deserve some thought. Yeah, we're definitely DFS. I will go DFS, and then put everything into a dictionary. It should be fine. Dictionary can handle that. And if it's too big, you can just do it section by section. You don't have to run the entire file system for it. And the hash, yeah, the hash is going to take the longest time. I don't know. How can you hash a file faster? I mean, if you start reading the file, you have a cursor to read. I mean, what you can do is just given some random position and put a cursor in a random position, right? And then for each file, just get those random position out, you hash it, and then compare the two. That's something else we can do. Of course, the more random positions you use, then the less likely there will be false positive. But to eliminate false positive completely, I think you'd have to read the entire thing. But we can compute the probability, right? Depending on the size, and then for 2 files to be false positive, which means they're exactly the same. Let's say 1 KB, right? So let's say we have 1,000 random bits, right, in the file we take out, and then for all of them to be exactly the same. So each one could be a 50-50, right? So it's 1/2 chance that it will be. Oh, hold on, that's actually awesome. I need some calculation to see if all of them match, but the remaining does not match. What is the likelihood? Actually, I don't know. If all the bits match, then it's a 0, right? If this match and the last one doesn't match, that's 50%, right? A 50% chance. If we have n minus 2 bits match and have 2 does not match, then it's 50 times 50, right? Chance that it will. Oh, it should be higher. So it's 1 minus 50 times 50. There's a chance that they will not match. Wait, no. Oh, yeah. Let me just count how many different possibilities that they will not match. Actually, there's more possibility they will not match. This is 3 over 4. No, this analysis is not right. Anyway, let's do this first. Dupes. P in path. So what do? We are going to split. P list equals P dot split by this. I'm pretty sure this is directly split, right? So we have the root, the path, and the files. And then for I in range 1 to len P list, for each one we can split again. Yeah, split is easier to deal with. We'll just split. Oh, we might not have it. Oh no, I think they are all in this format. Split based on left parentheses. So we're gonna say file name, we'll call fn, content equals p list I dot split left parentheses, right? Then we can say duplicates content, not the last one, because that's the right parentheses, dot append p list 0, which is the path, and we need to go a slash, and then file name. So once it's done, we can return list dupes dot values. Let's see. Paths. Find duplicates. Well, we have to go answer our sort. That's the sort. Okay. Oh, we might miss something. Yep, we missed something. I saw this, I knew it. What is this case? Oh, wait, what? Was asking for duplicates. No way, this is expected is nothing. It's asking for duplicates, so we have to say return for val in dupes.values if len val is larger than 1. There we go. We'll change this. Didn't learn, huh? I didn't realize. That was early. 6:33. Maybe that's CA time. Yeah, I don't know. 8 days. All right. That's that. $609. The only tricky part is the return value, which has to exclude all the files that do not have duplicates. Let's do this. All right, let's see. I want to see the answers to the others. Hash map. What are the follow-ups? There we go. Oh. Which are located close to each other are also accessed one after. That makes sense. Why is BFS easier to parallelize? Well, because once you visited, you don't need to visit it again. Because it's all the children's are out. Yes, that's true. Compare size. Hash. Bye. Oh yeah, why do you need a lock? You don't need a lock. Well, if other things are working, no, you're just reading. But you're also reading a file. You don't need a lock to refile. But what if other people or the systems are writing to it at the same time? Yeah, I guess it is. And the total number of strings, and then, yeah, ONX. Yeah, you can say that. All right, so we're done with this one. Size hash byte by byte. Byte by byte. Okay, let's try this. Remove all occurrences of a substring. I do not like strings. Anyway, wait, doesn't Python has this? It has a helper function for this, right? I don't know. Maybe. Do I have remove substring? Remove a character. Is replace. Oh, replace. I can use rejects for this. Oh, hold on. You can't, because it shrink the thing. Ha! Oh man. Until all occurrences of the substring removed. Leftmost occurrence of part and then remove it from S. So in this case, if I remove ABC, I remove this. Then I have a next ABC, I remove it. Then I have A and BC, then I remove. This is like playing a game, you know? Yeah, I remember. It was a game my mom loved to play. Which is, oh, I forgot the name. It's a toad. You know, a frog, a toad, was spitting out balls, and the balls will go around the track, and then you can shoot a ball, and if it's a 3 or more, that will disappear, and then the balls in the front will smash back, and if it's additional matching, it will disappear again, and then you get more points, like a combo. Yeah, I remember. What's the name of the game? I forgot. It has a like a Maya kind of theme to it.
From Mexico?
Yeah, I feel like Mexico kind of thing. I forgot the name. Oh, my mom loved that game. Can spend the entire afternoon playing it. I forgot. This question is exactly that game. But what's the name of the game? I want to look for it. It's fun. It's a fun game. I got bored fast, but it's interesting. It's a small game. This type of game is good. You won't get addicted to it, but you find it fun. Oh, my mom didn't get bored. My mom likes to play like some Chinese poker against computer, and she will yell at the computer, "Why are you so dumb?" And my father and I, we just laughed. Like they are AI. Not even AI. They're just programmed to do certain things. You can't be mad at them. All right. Anyway, how do we do this? Man, X, Y, X, Y, X, Y. Oof. 1,000. 1,000. Which suggests that we might be able to do O(n) squared on this. So we can scan once to find all matching, because they can be removed without issue. Oh, are you sure? Yeah. If it exists, then I think it can be removed without issue. Unless the substring is like AA. Damn. I can see that. The test case can be S is A with a B and A to the end, and the part is just AA. Which in that case, we'll remove that. I'll remove that. That's actually not that difficult a case. So I do think we can remove all the substrings, all the parts, right? And once we remove all the parts, then we get a new string. I don't know. Maybe just reject, replace it, and replace it? That could take a while, but maybe we'll pass. You want to try? Yeah, let's try. Do you know the syntax? I don't. I'll figure it out. Syntax of rejects. Replace. And I can replace all of them. I don't really care. right? Actually, I need to see rejects. Oh, it's called sub. Replacement string. Now I don't want to compile. I want to read.sub. Pattern. Return the string by replacing the leftmost. By replacing this. If the pattern isn't found, string function is a string. Do you have sub all? Sub n. Okay, so we're going to do sub n. We just do pattern. What's replaced in a string? I just get a new string. I don't even count. So basically, we can say new string, a number of subs made. So while true, read.subn part, right, s, and then will give me s and num replaced. Let's call it num. If num is 0, then return. I mean, I could just do, say, num equal 1. And then say while num, we do this, and then return s. Probably won't pass in an interview. They probably want to do it, but I think if this path, it is a solution, right? It is a solution, and the speed will be determined by how fast rejects is. String pattern. Oh, the replace. Shoot, this is the replace. Yeah. Let's see. I think it'll work, but it will be slow. Ooh, hey, it didn't work. Did not work, man. Little trick did not work. Output AB, expected BA. Alright, let's see, why is BA? AB, oh shit, A, BA, BA, BA. So we do ABA. Oh, it should be ABA, that's why it's BA. So, now we have to do true, then we do sub, We'll say new s. If s equal to new s, then break. Although and we say new s equal new s. Huh? That's interesting. Last one still didn't work. S and new s. Wait, isn't sub just sub out 1? Non-overlapping occurrences. What's the difference between this and sub n? Oh, just a return. Oh, it's the same thing. Unless you do count, right, I guess. Okay, we'll just do count equals 1. Then we can use the previous one. We can use this, but we'll just add a count. Yep. Make sure every time I want to replace once. Yeah, it's slow, it's bad, not what is intended to be, but I guess it's fine. I mean, for this, we probably can use replace. Yeah, that's all right. This is probably a cheat by using regex to do the replacement. But we can, I think we can be able to do dot replace. You can try using string dot replace. Use string dot replace. Let's see. I'm gonna start with new s equals s plus. Let's just found true. We can say new s equals s dot replace part nothing. So if new s is equal to s, break. Otherwise, s equals new s. You gotta be kidding me. Replace is also replace all. There's a documentation. How W3 school appears before Python's official? I don't understand. All right, let's say replace. Here's format. You can't even use this. They have this one. All occurrences will be replaced if nothing else is specified. We have to specify count. How many occurrences? So we have to count as well on this one. Really? Huh. Interesting. How is this achieved? I guess you can achieve this. Yeah, I mean, the reason that I'm bold enough to just do this is simply use string replace directly. It's simply because it's only 1000 in size, so it's always going to work. Oh, look at this. You don't have to run the regex machine, and everything is fast. No regex machine, no regex, much faster. So what else? That's it, right? Any fancier method? Since only 1000, I think that's... I don't think so. Let's look at a hint. Maintain a stack of characters, and if the last character of the pattern size in the stack match the pattern, remove them. Oh, a stack! I think I know what you're talking about. So D, A, A. So we have to go 3, right? So D, A, and then we always check the last 3. B doesn't match. C, boom, match, pop it. Ah, I see. I know. Now I know what this testing about. Yeah, it's stack. So this is from hint. From hint, we know that the problem is about stack. All right. So we say stack equals this for letter in S. If len stack is have you ever thought about don't use stack? Would you say if this is larger or equal to len part and let's do n equals len part. How about this? So this is larger than n and stack minus n to the n is equal to part. Then, holy crap, we say stack equals stack to this. Otherwise, stack plus equal to letter. Right? So initially it's smaller, so just plus, 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 and suddenly it's larger 2, and then we check. If it's not equal, we just, and then eventually we're going to return stack. This is interesting. Okay, the first one didn't work. How? DA, we have ABC. BA, ABC. We have to do it one more time. We have to do it one more time. How can we make how about we add it first? That worked. Not too bad. ONM. Alright, because we have to do this. But this is I don't know, string concatenation. Yeah, I think it's OM. We can count this ON or OM, which is fine. I mean, we could have just using a real stack, a list, and we just join. So that's always ON. We can try. Using a real stack. Letter is larger than N, and the join. And pat. Wait, why do you do that? Seriously, we don't need this. I got confused, sorry. That's exactly, because we have to pop them. And then we do, I'm pretty sure it's the same. No, it's not the same. It is faster. Faster than string concatenation and slicing. Also faster than string concat and slicing. A stack. Didn't realize. I was going straight into replacing. And replacing might not work actually if the size is huge, right? Let's say S is 10 to the 5 and a part is 100 or 1000. Then this won't work because this is just too much, right? This is too much. And this will still work. Yeah, seriously. So this is 1 million, right? So we put a 0 here. We might put another 0 here. So I would do 10 to the 5th on this and only 10 on this. Then I think these methods will not work anymore. So I count this as a hint. All right, anyway, that'll be it. See you guys tomorrow. Adios.